Hello, everyone. I'm Frank, and welcome to episode 24 of Learn How to Sudoku, where we take very easy variant Sudoku puzzles and break them down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Coffee and Cinnamon Roll by Fabian Johnson Lee. And here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. Little killers. Digits out along the marked diagonals sum to the numbers next to the arrows. So, for example, these two digits along this diagonal add up to 13. These two digits add up to 13. These 6 digits add up to 12. These 4 digits add up to 14. These 6 digits add up to I can't get it there. These 6 digits add up to 18, and etc., etc. And that's how little killers work. Palindrome. The gray line is a palindrome, meaning the same sequence of digits populate the line in the same order as seen from the center of the line. For example, let's see if this works. 1, 2, 3, 4, 5, 5. Okay, this doesn't work for this specific line. But say you had a palindrome line. Say it cut off right here, right? And this would be 1, 2, 3. Actually, not there, but 4, 5, 5, 4, 3, 2, 1. So say it cut off here, right? This was the full palindrome line. Then this would actually work as a palindrome line. And actually, interestingly enough, it does kind of work, except that this extends to here. So it does not. So this example obviously would only work if it cuts off here, but it doesn't. So that's how palindrome lines work, though. They have to read the same one way as they do the other way. So basically, this palindrome reads the same going this way as it does if it were read this way. Right? Along this spiral. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. So, we know these digits specifically. Well, there's 6 digits adding up to 12. What's the minimum in each box? The minimum for these 3 cells is 1 plus 2 plus 3, which is 6. And the minimum here is 1 plus 2 plus 3, which is 6. Therefore, this must be exactly the minimum. So these, because that adds up to 12. So this is 1, 2, 3, and this is 1, 2, or 3. Well, we know this cell is exactly the same as this one. This cell has to be the same as this one. And we can go along this to basically try to map out where these cells are. I like using colors because it makes it easy visually to see these things. This will make it, I don't know, orange, I guess. These are red. These two are the same. We'll make them medium gray. And these two are the same. They're dark gray. Okay, so this is the palindrome line. So to make it read the same forward and backwards, this must be the same as this digit, right? Which means this must be the same as that digit, etc., etc. We know orange is a 1, 2, or 3. This is the pink 1, 2, or 3. Red is the last. Well, we don't know. Red could be the same as the pink. We're not sure. Red could be, okay, so red has to actually be orange or pink. So it's the same as orange or pink. Because, yeah, there's no other It cannot be the last 1, 2, or 3, right? So the medium gray cannot be red and cannot be pink. So it has to be one of these two. So we know the red is one of these two then. The red has to be one of these two. Because it cannot be that one. The gray cannot be the pink, so it has to be one of these two. And this color, I don't know. We're gonna label this A, I guess. A cannot be orange, but it could be one of these two, right? We know red. Oh, we know both of these are 1, 2, and 3. Okay, that's interesting. So these two have to be 1, 2, and 3 because they're red and medium gray, right? Well, since that's the case, we know those two with another digit and 3 other digits must add up to 34. What's the max this could be? It could be 2 and 3, which would mean that this would be 5. This max could be 24. So that doesn't tell us very much. It does give us degrees of freedom, so we should probably talk about that. Oh wait, this orange is a 1, 2, or 3 also. Okay, yeah, we have... Okay, so what's the maximum that can be along this diagonal? Well, you could have a 3 here. You could have a 2, 3 here. That adds up to 8. You could have 8 and 9 here, which would be 17. 17 plus 8 is 25. And then you could have a 9 here, which would be 25 plus 9 is 34. So we know this is exactly the maximum that's possible along this diagonal. Therefore, this diagonal must contain the maximum values here, which forces this to be a 3. And we know these are 2 and 3. So this is 2 and 3, and therefore this A has to actually be a 1. So this is 1, this is 2 and 3. This has to be a 9, which means this has to be 8 or 9 here. So this is 8 or 9. Okay. What does that tell us here? I'm not really sure. Okay, so this is a maximum of 34. Well, we know it's exactly 34, and that's the maximum. This is exactly 12, and it's the minimum. What about these? What's the minimum here? Well, this has to be at least 4, and this is at least 4, and this is at least 1 and 2, right? Well, that minimum then is specifically 4 plus 4, which is 8, plus 3, which is 11. So that means to get from 11 to 14, we have 3 digits, or 3 digits can change in going up, right? Because we have already the minimum, and things can only go up in value, but you can only go up 3 total. That means, and this is what I like to call degrees of freedom, right? From the minimum, how much can you go up to get to the actual value, right? And in this case, it's specifically 3. And it's the highest digit that can go up 3, right? Because if you tried to make this 1 and you tried to make you could essentially make the 1 go up 3, and that would be 4. but that's not giving us the largest spread that you can have, right? Because the 2 could also go up 3 and go up to 5, and then you would have 4, 1, 5, and then 4, adding up to 14, right? 4 plus 1 and 5 is 10, plus 4 is 14, obviously. So this can be 2 raised up to 5, because you have 3 degrees of freedom, and these could be 4 going up to 7 in the corners here. Here you have 2 digits adding up to 14, so it's either 5, 9, or it's 6, 8, because those are the only pairs of digits that can add up to 14. Let's see. What's the minimum here? Would be maybe the question, right? So this orange has to be a 3, so therefore this is a 3. This cannot be 3 then, and this cannot be 3. So we're going to remove the orange coloring, because we already know that those are already set. So these two are the same. This could be red, or it's gray. So this is red or gray. This, one of these would be red, and then we know one is one of those two. So this is, we don't need the A there. Okay, so along this line, what can these values be? Well, this cannot be 2 or 3, obviously. So because we have a 1, 2, 3 triplet in both box, well, cannot be 1, 2, or 3 because we have a 1, 2, 3 triplet in box 6. Well, actually, really a 2, 3 pair now with a 1 being set. And the reason why we knew that was because this had to be 2 and 3, so this had to be a 2, 3 pair, which eliminates 2 and 3 from the rest of the box, which made that a 1. And because of that, this is at minimum a 4, and it can go up to potentially an 8. But what happens if it does go up to an 8? Well, if this is an 8, that would force this to be an 8, and these would be minimum of 2 and 2 here. So that would be 16 plus 2 and 2, which would be 20, which is already greater than the value we have, which is 18, and that's not counting 2 other digits. So this cannot be 8. What if we tried 7 here? Same problem, right? The 7 would have to be in both of these cells. That would be 14. And these would be at minimum 4. So that would be 18. And this would be minimum 4. So that's 22. So it cannot be 7 here. Can it even be 6? I'm not even sure if it can be 6. If this is 6, this would be 6 and 6. That would be 12. This is at minimum 2 and 2. So that would be 12 plus... Actually, I don't think... Yeah. So if we had 6 and 6, that would be 12. Plus 2 and 2, that would be 4 plus 12, which is 16. Plus 4, which is 20 already. So this cannot be 6. What about 5? Even 5. If we have 5 and 5, I should have started from 5, because then that eliminates everything that's higher than it. Anyways, don't do what I do and going from the highest number to the lowest number. If you can figure out that beforehand, it won't work that way, right? Logically. This can't be 3 anyways, so this is 1 or 2. This is 5. So if we tried this as 5, that would be 5 then. This would be 10. This is at minimum 2 and 2, so that's 14. This is a minimum 4. This is a minimum 1. So therefore, this would be 19 at minimum, which is not the value. Therefore, it cannot be 5. So this must be a 4. We learned from all that, that must be a 4. So this can no longer be 4, and this can't be 4, which means we lose 1 degree of freedom. This can't be 4, which means we lose 1 degree of freedom. So we've lost 2 degrees of freedom along this 14. Now the minimum here is 5 and 5 with 1 and 2, which adds up to 13. So we have now 1 degree of freedom here. So this can't be 7, this can't be 7, and these can no longer be 4 and 5, right? Because we have 1 degree of freedom to raise a digit. If we tried to raise 1 up, it wouldn't work. So we know there has to be a 1 in one of these two cells, and it's either with 2 or it's with 3. Now, let's take the minimum here, right? If this, or actually, make this the 3. If this were a 3, this would have to be a 3 also, which would mean that we would have 3 and 4 added together, and this is 4 and 3 added together. So that would be 7 multiplied by 2, which would be 14. But this is minimum 5. 14 plus 5 adds up to 19, and therefore that doesn't work. So this can never be 3, which means we know this is a 2. So since this is 2, the red has to be a 3, which means this is a red. This can no longer be 2, so it must be 1, which makes this a 2. And we can remove the coloring now because we have already the palindrome part working. Since this is a 1, this has to be a 1 then. So that works. This is 2, 4, 4, and 2. What does that mean? This adds up to 12, right? 2 and 4 added together is 6 times 2 is 12. Therefore, these two digits must add up to 18 minus 12, which is 6. So this can never be 6 then. This has to be a 5, which forces this to be a 1. To basically maintain, to add up to 18, essentially. So since this is 5, this cannot be 2, this can't be 3, and this can't be 1. Therefore, this must be a 2. This can't be 3, so this must be 1. These 3 digits add up to 8. 5, 1, and 2 add up to 8. 14 minus 8 is 6, so therefore this is a 6. This can no longer be a 6, which means this can't be an 8, because it would have to add up to 14. And if this were an 8, this would be a 6. And we can't have that here. So this is 8 or 9. Let's see. We have, let's see, this. These add up to 26. So these 6 digits add up to 26. What's the minimum this could be? Well, this is at minimum. It cannot be 1, 2, 3, or 4. So this has to be 5, 7, 8, or 9. This is 5, 7, 8, or 9. This can't be 1, 2, or 3, but it could be 4 through 9. But because of the 8, 9, 8, 9 pair in box 4, this can't be 8 or 9. So this cannot be 8 or 9, and this can't be 5 because of this 5. So therefore this can't be 5. Similarly, this can't be 8 or 9 because of the 8, 9 pair in box 4, which eliminates 8 and 9 from the rest of the cells. So this could be at most 7 or 6. But this could be down to 2. So it cannot be 8, 9. It can't be 1, 3, or 4. So it's 2, 5, 6, 7. Okay. Let's look at the minimum possible here, right? Say we looked at the minimum. Actually, say we looked at everything minimum, but this being actually, let's say we looked at the minimum here. So the minimum would be 1 plus 6 and 5, so that would be 12. 4 and 8 and 2. So the 4 and 8 adds up to 12, so that would be 12 plus 12, which is 24. And then 2, which is 26, which is the value of this diagonal. Therefore, it has to be the minimum. So therefore, this is a 5, this has to be 4, this has to be 8, and this has to be 2, right? So you have 2, 4, and 8, which adds up to 14, 5, 1, and 6, which adds up to 12. So 14 plus 12 is 26. So that works. Therefore, this can't be 8. This is a 9. There's an 8. This has to be a 5 to match this palindrome. This has to be a 4 to match this palindrome. And we don't need the other coloring there to match this. Okay. This can no longer be 9, so therefore this can't be 5, because again, these have to add up to 14, and removing one digit removes the corresponding digit that goes with it. This can't be 8 because of this 8, so this is a 9, which means this has to be 5 to add up to 14. Okay, we'll remove the colorings because it's kind of distracting. And how I like to usually solve these then is usually figure out what everything can sort of be. But that might not be possible. It might just be better just to actually look at the Sudoku stuff to try to figure these out. Where is the 1 in box 4? Cannot be any of these or these. So it must be in the last remaining open cell, so this must be a 1. What about in box 7? Well, box 7 we know it could be one of these two, so that's not helpful. 2s. 2s we can eliminate. We've eliminated a lot from box 5. Can't be here, can't be here, can't be here, so it must be here. So this is a 2. And it's kind of, yeah, we don't know with these. Actually, these I would like to actually set these. So we have 2 digits adding up to 13. What are the possibilities? It could be 4 and 9, but 9 cannot be in either of these 2 cells. So this specifically cannot be 4, 9. It could be 5, 8, but this can't be 8. But this could be a 5. Oh, we'll put that in pencil mark. So that's a 5. That would then be an 8 if that's the case. Or it could be 6, 7, right? And either of them can be 6 or 7. Similarly, we could have a 4, 9 here, but the 9 can't be here, so this would be 9, and this would be 4 if it's 4, 9. If it's 5, 8, this can't be 5, so therefore this would be 5, and this would be 8 if it's 5, 8. Or if it's 6, 7, it could be 6 or 7. Let's see. Does 1 give us anything in any of these? Not really. What about 3? 3 might give us something. So 3 cannot be here, and 3 cannot be here. Where is it in box 5? It has to be here. Oh, and this is, I count this box 5. We, by convention, we number these boxes in Western reading convention. So that's normal in typical Western reading convention. So that's usually from top down and from left to right. So this is box 1, this is box 2, this is box 3, this is box 4, 5, 6, 7, 8, 9. So where is the 9 in box 5 now? It can't be any of these cells because of the 9s, therefore it must be here. The remaining cells are 6 and 7 in box 5. The remaining cells in row 6 are 6 or 7. Where is the 8 in box 6? It has to be here. So this is 8. The remaining cells in row 4 has to be 6 or 7. And where is the 5 then in box 4? Can't be any of these cells, so it must be here. Which makes this a 6 or 7. And we're missing 6, 7, and 9 in the rest of box 6. Or row 5, however you want to put it. Where is the 9 in box 8? Cannot be here, cannot be here, cannot be here. The last remaining cell that's open is here, so this must be a 9. The remaining cells in this, then, are 4, 7, and 8 for box 8. It's 4, 7, 8, but this can't be 4, and this can't be 4. Therefore, where's the 4 in box 8? It must be here. So this is the 4. Okay. 5. Okay, where is the 5 in box 2? Cannot be here, cannot be here. The last remaining cell that's free is here. So the remaining cells must be 6, 7, 8, but where is the 8? Cannot be here, it must be here. So this is a 6, 7, 6, 7 pair in the rest of box 2. This can no longer be 8, so therefore this can no longer be 5 to add up to 13. This is 6 and 7. We have a 6, 7, 6, 7 pair in row 1. So 6 and 7 cannot be in the rest of the row. So this can never be 6 or 7, which means this correspondingly can't be 6 or 7. And this can't be 8 because of that 8, so therefore this must be a 9, which forces this to be a 4 to add up to 13. This can no longer be 9. We now have a 6, 7, 6, 7 pair in box 6, which eliminates 6 and 7 from the rest of the box. So therefore this is a 9. Where is the 9 in box 1? We cannot have a 9 here, or here, or here. The only remaining cell now is here. Similarly, in box 9, just by normal Sudoku, these are eliminated. Therefore, this must be a 9. So this is a 9. We have a 7, 8, 7, 8 pair in row 8, which eliminates 7 and 8 from the rest of the row. What are the remaining digits? It must be 3, 4, and 6. This cannot be 3 and 4. Therefore, this must be a 6. Therefore, this is a 3 or 4, and this is a 3 or 4. Okay, and now this is probably just all killer Sudoku stuff now. Where can the 1 be? 1 can be still in multiple places. 2's can be in multiple places here or here. 3's can be in multiple places. 4's. 4 we can actually limit. So in box 1, where is the 4? It cannot be here because of normal Sudoku. Can't be here because of normal Sudoku. Cannot be this one because of the little killer clue that we have. So it has to be here. So this is 4, which means this cannot be 4. So this is a 3, which makes that a 4. Where is the last remaining 4? Because we have 8 4s now. It has to be here. So this is 4. The remaining digits in column 1 have to be 1, 3, and 8, right? 3 cannot be here because of this 3. 3 can't be here because of that 3. Whereas the 3, it must be here. So then that's 3 in the corner. We celebrate because we're getting closer to solving it. This has to be 1 or 8. This is 1 or 8. What are the remaining digits in column 2? Well, we have a 6, 7, 6, 7 pair, so that eliminates 6 and 7, and all the other digits are accounted for here, so it must be specifically 2 and 5. This can't be 5 because of these 5s, therefore this must be 2, which makes this a 5. Let's see, what else do we have? In column, actually, let's just go here. The remaining digits here are 1, 2, and 8. This cannot be 1, so this is 2 and 8. This cannot be 8, so this is 1. Or it can't be 2 either, so therefore this has to be a 1. Because those are the only digits remaining, therefore this can't be 1. This has to be an 8, which forces this to be 2. This 8 means this can't be 8, so this is 1. This has to be 7 or 8. And this is 7 or 8. Now here we have 3, 6, and 7 remaining as the digits in row 2. This can't be 3. Where is the 3? It has to be here. So this is 3. This is 6 or 7. The remaining digits here have to be 5 and 8 because of the 6, 7 pair here. This can't be 5. Therefore, this is an 8, which forces this to be 5. Where is the last remaining 2? It has to be here. Because we have 8 2s, and that eliminates all the other possibilities, so that's 2. What about the 1s? We should have 8 1s also. Yep, we have 8 ones. Where's the last remaining one? It must be here. So therefore, this is 6, 7. So now we have a 6, 7, 6, 7 pair in column 8, which eliminates 6 and 7 from the rest of the column. Therefore, what can this be? This has to be 5. This cannot be... Where is the 3, actually? The last remaining 3, because we have 8 3s, cannot be here, cannot be here. It must be here. So this, that's 3 we celebrate. This has to be specifically 7 or 8. This could be 6, 7, or 8, and this is 6 or 7. So how do we solve this problem, right? We have a lot of different 6 to 7 pairs here. Well, the easiest way is to just designate any color a certain color. So I'll just randomly say this is green, and we're going to make this, I don't know, yellow. So if it's one color, it obviously has to be the other color if it's a 6, 7 pair, right? Therefore, this has to be green. This has to be yellow, because it cannot be green. This has to be then green, which makes this yellow. This green sees that one, so this must be yellow, which means this has to be green, because this is yellow. That makes this yellow, and therefore this is green. But the interesting thing is when we start getting to these parts, right? So this can't be green. This has to be yellow. This can't be yellow then because it has to be green. So where is the yellow? Okay, well actually we didn't even need to do that. My apologies. We didn't even need to get to that far point. This 6 means this can't be a 6. So this is therefore 7. Which makes that a 6, which makes that 7, and then everything basically it collapses in a sense. If you think about it from a perspective of Heisenberg's uncertainty principle, which we don't have here. This is 6, this is 7, this is 6, this is 7. This can no longer be 7, therefore this is 8. This can't be 7 or 8, so it must be 6, which means this is 7. This is 6, this is 7, this is 6. This can't be 8, so this is 7, this is 8, this can't be 7, so this is 8, and this is 7. Apologies for making that a little bit more complex than it needed to be. I should have just basically seen this 6 and then basically been able to deduce this had to be 7. Anyways, this cinnamon roll was very interesting as a palindrome line. I hope everything made sense and was very clear to you guys. I'm trying to make it a little bit more clear in these Learn How to Sudokus, but sometimes I make assumptions in my mind that I don't translate to essentially my mouth. So, anyways, if you have feedback, let me know. Or if you liked it, if you enjoyed it, just also let me know. And I'll see you next time on Learn How to Sudoku. Thanks a lot.